Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11b in the great state of Texas, and we are using item number 28 off the Redesign Practice Online STAR Test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this expression here, and we need to simplify it. So let's draw. And honestly, the easiest thing to do here, we need to know first off that x and y are defined. What that means is they cannot equal 0. X cannot equal 0, y cannot equal 0, because if we end up with 0 in the denominator, we divide by 0, weird things happen. So what we need to do here is watch. Let me separate each of these terms. I'm going to take x to the negative 6, y to the 4th, x to the 3rd, and then y. It's just y on its own, y to the 1st. And watch what we can do here. We can just kind of split it like that. And we could do this. X to the negative 6 over x to the 3rd times y to the 4th over y. That's perfectly legitimate. Why would we want to do that? Well, because we've got like terms. Look at the bases here. I've got two different x's, right? I've got an x, and then I've got a y and a y. I can do things with that. If I have an x over a y or a y over an x, they're not like terms, and I can't do anything with that. So what we need is we need to open up our reference materials. Let's take a look at our laws of exponents here. So I'm going to go right here, properties of exponents, okay? And let's look at the quotient of powers, because really what I'm doing here is I'm dividing powers right here, okay? So quotient of powers, see that up at the very top? What does it say? Well, if you take your a to the m divided by a to the n, you can end up just subtracting those two exponents. It's a little bit counterintuitive when you divide, you subtract, but it's because the bases are the same. So here's my base, a and a, similar base. Then you can end up subtracting the exponents. Okay, so let's do that with each of these. Let's start with the x's. Okay, so I've got x, that's my base, and I'm going to take negative 6, and then I subtract, right, minus 3. Okay. Then let's take my y. Okay, so I've got y to the 4 minus, okay, there's nothing there, but if there's nothing there, you can always say it's to the 1 power, right? Any fraction or any number, anything, quite honestly, can be taken to the 1 power, and it's just itself, right? It's just the identity principle. So we can actually just think it's 4 minus 1. Because we have to subtract something, okay? So what does that give us? That gives us x to the, and ends up being negative 9, y to the 3rd, okay? Now, that x to the negative 9 should make us look at that third one right there, that negative exponent. Okay, the negative exponent in the properties of exponent tells us that if we have a negative exponent like a to the negative n, you end up taking the reciprocal. 1 over, and then a to that same power to that n. Okay? So x to the negative 9, this is the same as 1 over x to the 9th. Okay? We multiply that by y to the 3rd. You're going to end up getting this y to the 3rd over x to the 9th. So let's see what we have here. Y to the 3rd, x to the 9th. We do see that. That answer is right there at the very top. And so our answer here is going to be A.